All right, we're going to work example 1 from section 4.4, absolute maximum and minimum. All right, the extreme value theorem tells us if a function f is continuous on a finite closed interval AB, then f has both an absolute max and an absolute min on AB. All right, let's think about it. Closed interval from A to B. Think of drawing some kind of function. Okay, that's continuous. Let's see. We have an absolute minimum somewhere, and we have an absolute max on this one. This happens to be my absolute max up here, this f of x value. This happens to be my absolute min right there, my f of x value. Now, where can these absolute maximums and minimums occur on a closed interval like this for a continuous function? They can occur in either the endpoints here, A or B, or they can occur at these critical points here. All right, so let's work our first example that we have. Find the absolute max and min values and state where they occur. Notice what we're dealing with here. We're dealing with a closed interval. How can I tell? Because of the brackets. All right, so what do I need to do? I need to actually go through, find my critical points, and evaluate my original function of my critical points. Then evaluate my original function at each one of these endpoints right here and see which one's the largest. That'd be my max. Which one's the smallest? That'll be my absolute min. Let's go through and do this, okay? How do I find critical points? Well, let's find a derivative at prime of x. All right, so that's 29 minus 58 cosine of x. All right, now, what do we do with this derivative? We find out where it's undefined and where it's equal to 0. So let's set it equal to 0 first of all. 29 minus 58 cosine of x. Let's find out where that's equal to 0. So we'll have negative 58 cosine of x is equal to negative 29. Then we divide both sides by negative 58. And we end up getting the cosine of x is equal to 1/2. So what does that imply that x is equal to? Well, let's see. What are we looking for? We're looking for the angle whose cosine is 1/2. The angle whose cosine is 1/2. Let's see. If I think about the unit circle, the angle whose cosine is 1/2. Doesn't that happen somewhere around right here on the unit circle from trig? We memorized those particular points, and we had a point that was 1/2 square root of 3 over 2. And which angle was that that gave us where this cosine was 1/2? That was angle of pi over 3. So x is equal to pi over 3 is one answer. Now let's look at anywhere else that I have an angle whose cosine is 1/2. Well, my cosines are positive here, negative here, and positive here. So what about at a reference angle here at pi over 3? Well, I'm going to have the order pair 1/2 comma negative square root of 3 over 2. Now, isn't my cosine 1/2 again? But what actual angle, or which actual angle is that? That's what? 2 pi, because think about 2 pi all the way around, and then back off this amount, back off pi over 3. So 2 pi minus pi over 3 is 6 pi over 3 minus pi over 3, or 5 pi over 3. So x is equal to 5 pi over 3. And actually, if you think about these multiples of 2 pi, so anytime we go around, actually if you add 2 pi to each one of these, you'll get at another cosine that's 1/2. But we're only looking at an interval from negative pi over 4 to pi over 2. If this is only a 1/2 pi we're going up to, 5 pi over 3 is not included in that. where I'm looking anyway. All right, so the only angle I have that's in this interval right here where my cosine is equal to 1/2 is pi over 3. So I just found where my derivative is equal to 0. Now my derivative is not going to be undefined anywhere, so I don't have to worry about that. All right, so what do we have to do now? We have to take my original function, which is right here, and we have to substitute in this endpoint in for each one of these x's, substitute this endpoint in for each one of these x's, and substitute this critical point in for each one of those x's, and see which one is largest, that's my absolute max. See which one is smallest, that's my absolute min. So I'm going to take f, I'm going to evaluate it at negative pi over 4. I'm going to take f, I'm going to evaluate it at pi over 2. And I'm going to take f again, and I'm going to evaluate it at pi over 3. All right, so what do? We substitute in the values in for each x. Oh, so we have what? 29. You know what? I'm going to run out of board space if I do this, so I imagine y'all can all handle this part. So at pi over 4, or negative pi over 4, if I evaluate, I get negative 29 horse pi plus 29 square roots of 2, if I simplify. Let's see, at pi over 2, I get 29 over 2 pi minus 58. And at pi over 3, what do I get? I get 29 thirds pi minus 29 square roots of 3. So we just need to determine which one of these is the largest and which one of these right here is the smallest. Well, it's kind of hard to tell by just looking at this. So we get an approximate value for each one of these. We can plug it into our calculator, calculate an approximate value. And I got something like 18.24 for the first one. The second one, I got something like approximately negative 12.44. And the last one, I got negative 19.86. All right, now it's easy to tell the largest value. This is the largest value. So we're going to have an absolute max. This stuff, we don't want to use an approximate value when we're listing our absolute max. The only reason we use this so we can tell where it's at. All right, so we have an absolute max of negative 29 over 4 pi plus 29 square roots of 2, and it occurs at the x value of negative pi over 4. Okay, we have an absolute min of, well, negative 19 is certainly smaller than negative 12, but I want to use the exact value here. So we have an absolute min of 29 thirds pi minus 29 square roots of 3, and it occurs, we're out of space here, so I'm going to have to put it here, occurs at x is equal to pi over 3.